Hello and welcome to Spy Math, and this will be a 5-part series on logarithms as requested by some of my summer school students. This is Mr. Spy, and let's begin. Part 1, an introduction to logarithms. Okay, let's go over some basic facts about the logarithmic function. Logarithms are the inverse of exponents. An inverse, just to remind you, switches the input with the output. The basic logarithmic function is as follows. Y equals b to the x. We switch to log base b the power becomes the output, and the result, the exponent, becomes the input. The common logarithm has a base of 10, also called a Napier log. The natural logarithm has a base of e, denoted as natural log, as ln. To remind you, the base e is the irrational number 2.718, and a binary logarithm, which is used sometimes in computer science, has a base of 2. The symbol for log looks as follows: L O G, which is base 10. Okay? And that's what it looks like. Let's look at some facts about the graph of logarithms. Okay, the graph of a logarithm looks like this. It has no y-intercept. It has a vertical asymptote at the y-axis. Its domain is x is greater than 0. We'll see in a later lesson how to find a domain. It's not that. The range is all real numbers. It has an x-intercept at 1, 0. The function does not usually have a y-intercept unless it's shifted. We'll go over how to find the y-intercept in a later lesson. If you want to see how to actually graph the logarithmic function, let's pull up our calculator. Pull up our calculator. You go to y equals. You type in log x. The log button is right by the number 7. Hit enter. You want to make sure you have an appropriate window. This is a perfectly good window, 0 to 100. Scales of 10. Y minimum -3, y maximum 3. Because 10 squared is 100, so you want to see at least that much. Look at the graph. Look at the graph. You even can look at the table. You can see how slowly this logarithmic function grows. 10, we have 1. It goes really slow. And we skip ahead on the table all the way till 99. You'll see that by 100 is 2. Okay? Let's quit that, go back to the video. Okay. Now on to some basic examples without the calculator. You do many basic examples like the ones here without a calculator. Now I'll start with the first one, log. When log is base 10, there's no number. You just look at the number of zeros. Oops. The number of zeros that you see in the figure. In this case, it's 4. So this log of 10,000 equals 4. Log of 1 has no zeros, so it's 0 zeros. Scroll up. Log of base 3 of 27. Sort of asking 3 to what power equals 27. So which equals 3. Okay, next question. Log of base 2 of 16 would be 4, because 2 to the 4th power is 16. Log of base 4 equals 8. Well, it's asking 4 to what power equals 8. Not so easy to see, but you could change it by making something called a method of common bases. You write the first one as 2x equals 2 to the 3. Once the bases are the same, you drop the bases. So 2x equals 3. Divide by 2. X would equal 1.5. Okay? That's some basic ones out of calculator. Some more advanced ones without a calculator. If the base and the number inside are the same, it's always equal to 1. If the number inside the parentheses is a fraction, you automatically know your answer is negative. And 3 to the 4th power is 81. So it's negative 4. Log of base 9 of 3. This is going backwards. This is asking 9 to what power would give you 3. Well, that's sort of a square root, and the square root is the half power. Also, if you notice, the base, here the number is the same. You just take the exponent, which in this case is 1/3. And similarly, the log of base 4 of 7 to the square root of 16. Square root of 16, 7 to the root of 16. 16 is also 4 squared. Rewrite this as log where's that? Weird. Let's try it again. Maybe a thicker marker. Log of base 4 of the 7th root of 4 squared. And you rewrite it as an exponent. Log of base 4 of 4 to the 2/7 power. That means our answer is 2/7. Okay? On to some questions that would require a calculator. Okay? Based on your model of the calculator, it matters how you input a log. For most calculators, you'll need the change of base formula. Log of A equals log of B. Let's do these problems in order. Let's pull up our calculator. Okay? The first one, log of 50. You just type in log 50 and round your answer to nearest thousandth. Be sufficient. 1.699. The log of 50 is 1.699. Sometimes they'll ask you to find a natural log. So you go to button below log, which is natural log. Type in 3.2. Should be a little more than 1. 1.163. And you really should use the approximately equal sign for all of these. So it's 1.163. Change that to approximately equal. Make sure I'm set this right there. Now, next one, log of base 2 of 6. Now, if you have an older calculator, you just type in log of 6 divided by log of 2. It's not 3. And you get 2.585. Approximately 2.585. And the way I typed it in, let's see, is log of 6 divided by log of 2. Now, if you have a newer calculator, like the TA84 I'm showing on the screen, you could also hit alpha, then window, scroll down to option 5, which is log base, hit enter, type in exactly the way you see it, log of 2 of 6, and you get the exact same result. More often than not in the video, I'm going to use the log base, especially in this case, alpha, window, option 5. The base is 3.4. The input is 12.65. Hit enter and you get 2.074 approximately, the nearest thousand. 2.074. Okay, that's how you find logarithms with and without a calculator. That's it for part 1 on this series of logarithms. Come back for part 2, which shows you how to find the domain and the vertical asymptotes and the x and y intercepts of a basic logarithmic function. Thank you, and have a great day. This is Mr. Spy, signing off.